Astronomers begin doing something that seems straightforward. They measure how much starlight a galaxy contains, estimate how much visible matter is there, and then calculate how fast the outer stars should be moving. At first, the expectation appears simple. The farther a star sits from the crowded center of a galaxy, the weaker the pull should become. The outer regions should move more slowly. Then the measurements arrive. The stars near the edges are not easing back. They are not falling behind. They continue circling at speeds that the visible galaxy cannot seem to support. The mismatch appears again and again. The photograph suggests a lightweight galaxy. The moving stars suggest a much heavier one. A telescope can see the stars. It can see the glowing gas. It can map the bright structure stretching across space. Yet when astronomers add everything together, the numbers refuse to cooperate. The outer stars keep moving as though far more mass is present than anyone can actually see. That creates an immediate problem. If the visible galaxy contains most of the mass, then the motion should follow the visible galaxy. Instead, the motion keeps pointing somewhere beyond what appears in the image. Looking at the galaxy is no longer enough. The light points to one amount of matter. The motion points to another. The farther the measurements extend outward, the harder that separation becomes to ignore. A photograph no longer seems sufficient. Looking at the galaxy reveals where the light is. It no longer reliably reveals where all the mass is. And before accepting that something is missing, there is still a simpler possibility sitting on the table. Maybe the measurements themselves are wrong. The possibility of a measurement error does not disappear immediately. The observations are checked again. The calculations are repeated. The instruments are questioned. Then the same pattern appears somewhere else. A different spiral galaxy comes under examination. Its outer stars should slow down as distance increases. They do not. Another galaxy is measured. The outer stars keep moving faster than the visible matter seems able to support. Then another, and another. The behavior refuses to stay isolated. What first looked like a single anomaly begins spreading across the sky. Different galaxies with different shapes and different amounts of visible material keep producing the same contradiction. The images suggest one inventory. The motion suggests another. That changes the situation. A mistake can explain one observation. It becomes harder to use the same explanation when the same outcome keeps appearing in system after system. The expected slowdown never arrives. Instead, the outer regions continue moving, as though something additional is contributing to the galaxy's mass. The pressure starts building against the simplest answer. If the measurements are wrong, they seem to be wrong in the same way over and over again. If the calculations are failing, they are failing across many separate galaxies. The error explanation begins losing ground. What appeared to be an isolated problem now looks larger. The mismatch is no longer attached to a single observation. It is attached to a repeating behavior. The visible galaxy continues to say one thing. The motion continues to say another. And with every new galaxy that joins the pattern, a more uncomfortable possibility becomes harder to avoid. The missing mass problem may be real. The question is no longer whether the contradiction exists. The question is, what kind of mass could remain unseen? The search for the missing mass begins to produce a surprisingly simple picture. Instead of forcing the extra gravity into the bright spiral itself, astronomers spread it outward, far outward. The visible galaxy remains where it has always been. The stars still form the familiar disk. The glowing structure still occupies the center of the image. But around that visible galaxy, an enormous invisible halo is added. Nothing new appears in the photograph. No bright ring emerges around the galaxy. No hidden structure suddenly lights up. The image stays almost exactly the same. What changes is the amount of mass surrounding it. The galaxy is no longer treated as a thin collection of visible stars. It becomes the bright center of something much larger that cannot be seen directly. And something important happens. The motions begin matching the observations. The outer stars that once seemed to move too fast now have enough gravity to explain their behavior. The contradiction that kept appearing across galaxy after galaxy starts losing its force. The missing mass no longer has to sit inside the visible spiral. It can exist beyond it. The solution feels powerful because it changes so little about what is actually observed. The stars remain where they were. The measurements remain the same. The motions remain the same. Only the inventory changes. The bright galaxy stops being the whole system. It becomes the visible portion of a much larger structure. For the first time, the pieces seem to fit together. The galaxy looks ordinary because only part of it can be seen. The gravity appears stronger because much of the mass may be hidden from view. The possibility is difficult to ignore. Most of the galaxy may be invisible. Yet, even as the halo appears to solve the problem, another question refuses to disappear. What if the gravity is still coming from visible matter somehow, and the inventory is not actually incomplete at all? The halo remains a possibility, but a possibility becomes harder to dismiss when the pressure keeps arriving from different directions. The pattern refuses to stay confined to galaxy rotation. Every time gravity is measured, the same imbalance keeps resurfacing. The visible matter says one thing, the gravity says another. Every new observation creates the same physical consequence. Objects behave as though more mass is present than can be accounted for by what is actually visible. At first, there is still room to believe the inventory is incomplete only in small ways. Maybe some ordinary matter has been overlooked. Maybe enough visible material remains hidden to close the gap. But the gap refuses to close. The observations continue piling up. The required gravity continues exceeding what the visible universe seems able to provide. The pressure shifts from a single explanation to a broader reality. Something is creating the extra gravity. Whatever it is, it behaves as a dominant component rather than a minor correction. The visible stars remain visible. The glowing gas remains visible. The familiar structures remain visible. Yet they no longer appear to be the main source of gravitational influence. That belief begins collapsing under its own weight. The stars remain visible. The galaxies remain visible. But they begin to look less like the structure itself and more like lights attached to a much larger structure that cannot be seen. The invisible halo is no longer attractive simply because it is elegant. It is attractive because the observations keep demanding additional mass, whether anyone wants it there or not. The visible universe can no longer carry the entire burden alone. Some unseen component begins moving from possibility toward physical necessity. And that realization creates an uncomfortable consequence. If an unseen component dominates the gravity in galaxies across the universe, then the question is no longer confined to distant systems. It reaches much closer. What does that mean for the galaxy we live inside? For a long time, the problem seems safely distant. It belongs to other galaxies, other stars, other parts of the universe. Then the same picture is applied to the Milky Way. The same picture that appears elsewhere is applied to the Milky Way. The familiar band of stars stretches across the night sky. The visible galaxy remains filled with glowing gas, star clusters, and countless suns. Nothing about that view appears unusual. Nothing in the night sky announces that most of the system may be hidden. Yet when the larger gravitational picture is assembled, the Milky Way appears embedded inside the same kind of unseen halo inferred around other galaxies. The consequence is difficult to ignore. The problem was never confined to distant objects. It includes the galaxy that contains Earth. It includes the region where the sun moves through space. It includes the environment humanity has occupied for its entire existence. The stars remain visible. The constellations remain visible. The bright structure of the galaxy remains visible. But those familiar features no longer appear to represent most of the system. Instead, they begin to look like the illuminated fraction of something much larger. The shift is not visual. The night sky looks almost exactly the same. The shift is in what the night sky means. What appears to be the galaxy may be only a small visible portion of the galaxy. The bright stars become the part that can be seen. The dominant mass may be something else entirely, and that changes the final picture. The missing mass is no longer an abstract astronomical problem. It becomes part of the description of where humanity lives. Earth, the Sun, and every visible object in the Milky Way appear to be moving inside a galaxy whose largest component remains unseen. The stars above us have not changed. What changed is the realization that they may represent only a small, visible fraction of the system we actually inhabit.